Hello students. So in this session we are going to see a point from the chapter, that is magnetic field due to electric current, and one of the point which have been given in your chapter is magnetic force on a wire which is carrying a current. Now in this video we are going to derive, or we are going to see the derivation for a straight wire which is carrying a current I, and within this current carrying wire we will try, or we will see, or we will derive the magnetic force across this straight wire. So let's see. In our consideration, we have considered a wire, a straight wire which is of length L. Suppose L is the length of wire. Okay, if you observe properly in the diagram, we are able to see here the current I is flowing across this wire. Okay, so I is nothing but current across the wire. Then what you observe? Now we know if the direction of current flow is along this way, then what will be the direction of flow of charges through this wire? As we know, the flow of charges is exactly opposite to the direction of current flow. If we have considered the direction of current flow is towards this, then the flow of charges will be in opposite sense to the direction of flow of current. So the charges will move along this way. Okay, so this moving charge will definitely have certain velocity, and that is nothing but vector v suffix d, and this is nothing but, this is the drift velocity. Of the moving charges through that straight conducting wire, which have been mentioned in diagram also. Look here properly into the diagram. Here I is indicating the direction of current flow through the conductor. It is along this way, and v suffix d is indicating you the drift velocity of the electron, which is in opposite sense to the direction of current flow through that straight conducting wire, as we can see in the diagram also. Got it? Okay. Now we will try to find, or we will try to identify the direction of magnetic force. But firstly, we must know how is the magnetic field. As in our consideration, we have considered the magnetic field throughout this wire is perpendicular. If I am considering this is my conducting wire, in this case we have considered the magnetic field is perpendicular. That means the magnetic field is in this way. Okay, so here we will consider B is nothing but magnetic field, or I will say B is nothing but magnetic field which is perpendicular to length of wire. I will say L, perpendicular to L. Okay, B is nothing but magnetic field which is perpendicular to L, that means length of wire. Length of wire, this is the wire, and magnetic field is perpendicular, means in this way, okay, in upward direction. Okay, then now here we come to know B is nothing but magnetic field. Direction of current flow I we have known with respect to the diagram. Now we will try to find the force. Okay, now we will apply here right hand rule. Okay, as you know, we consider 3 fingers. Okay, this thumb indicate us the direction of force. This first finger indicate us the direction of current flow, and this middle finger indicate us the magnetic field. Okay, now we are interested here to find the force due to the magnetic field, that is F suffix M. Okay, now suppose this first finger is indicating us the direction of the direction of current. Okay, I. This middle finger is indicating us magnetic field. As in our consideration also, we have considered what? The magnetic field B is perpendicular to the current. Okay, look here. This is indicating direction of current flow. Magnetic field is perpendicular in upward direction. Okay, this middle finger is indicating us. And this thumb will indicate us force that is due to the magnetic field. So direction of force is in this way. Okay, in this way. So look into the diagram also. I have mentioned or I have shown you that this vector is indicating us force due to the magnetic field, and this force, that is F suffix M. Okay, force due to magnetic field, which we are interested to determine or to find in this derivation in case of a straight wire. Okay, so as we know, what we know, if I is the current flowing through a conductor, Q is nothing but amount of charges flowing through conductor. Then current I we are able to determine. Okay, how we determine current I? I is nothing but total amount of charges, I will consider Q, flowing through that conductor with respect to time T. So in this way, as we have seen previously also, we are able to find the current. Okay, but now in this case we will try to determine the charge Q through this straight wire. So if I rearrange this equation, I will have Q is nothing but I into T. But from our diagram, if you see properly, here I is the current flowing through our straight wire, of which length is L. Okay, and the charges which are moving through this straight wire, they are having certain velocity, that is drift velocity, which we have considered in our consideration also, as shown in diagram also. The direction of drift velocity is in this way. Okay, the direction of current flow is in this way. Okay, so as per our consideration, we have Q is nothing but I, that is current flowing through the conductor, into the length of that conductor or length of straight wire through which current I is flowing upon the drift velocity of the electrons or the charges which are moving through the conducting wire, that is V suffix D. So this equation we will have here, equation 1 I will say it. Okay. Now we are interested to find the magnetic field F suffix M, as in previous topic we have seen how the magnetic field is derived. So we are having the general equation to find the magnetic field is F suffix M, that is equal to Q into bracket vector V cross vector B. But as you can see, as per our consideration, the velocity of the electron have been given, and that is nothing but drift velocity. So it is given by V suffix D. So I can write the equation for F suffix M as per our consideration like F suffix M, that is equal to Q into bracket V suffix D, vector V suffix D cross vector B. Okay, so this I will consider it as equation 3. Now we will substitute equation 1 in equation 2, so that here we are going to substitute the value of Q, that is charges which are flowing through a straight conducting wire. Okay, now put, or you can say substituting equation 1 in 3. So we will have F suffix M, that is equal to I L upon V suffix D into bracket. Now look here, this is the cross product in between the two vectors. So how I will be able to write this cross product? Let's see. V suffix D, okay, V suffix D, I'll write like product of magnitude of two vectors, na? V suffix D into B into sine of theta and the unit vector n cap. Okay, now if you look into this equation, we are able to cancel this drift velocity V suffix D I am able to cancel here. So what I will have, I'll have the equation like vector F suffix M that is equal to I L B sine of theta into n cap. What is n cap? N cap is nothing but, I'll mention this equation 4. So here n cap is nothing but unit vector which is perpendicular to both magnetic field B and the drift velocity V suffix T, which is along the direction of this force F suffix M. Okay. Now what will be the value of theta here? If you look into the diagram, this magnetic field is perpendicular to the length of wire, or I can say this magnetic field B, this magnetic field which is pointing like this, okay, throughout the length of wire, in upward sense, I will show like this. Okay, so this magnetic field throughout the length of wire is perpendicular. That means this magnetic field will also be perpendicular to the drift velocity of the electrons or of the charges which are moving through that conductor. Okay, so here angle theta will be 90 degree. And what is the value of sine 90? As you know, sine 90 degree is 1. Okay, So equation 4 I will have like F suffix M that is equal to I L B. I L B into N cap I will say. Okay. So this is equation 5 which gives us force that is due to the magnetic field along a straight wire which is carrying certain current I. Okay, so this is the required thing in our derivation. Okay, but now one of the case have been given in your derivation also, in book also. If our first case I will say, if magnetic field that is B is not perpendicular to the wire, if our magnetic field is not perpendicular to the wire, then we will have the force throughout that straight wire like F suffix M that is equal to I vector L cross vector B. So this is another equation we are having in case of straight wire which is carrying current I. Okay, so this is the required thing. What we have found here? We have found the force due to the magnetic field in case of a straight wire which is carrying a current I. I hope you understand it better.